He's considered to be the oldest human mummy found intact, and scientists believe he died more than 5,000 years ago.
In the heart of the Alps, where glaciers have guarded their secrets for thousands of years, an extraordinary discovery lay hidden beneath layers of ancient ice. Frozen in time for over 5 millennia was a man who would one day become known as Otzi the Iceman. At first glance, he seemed to be nothing more than a remarkably preserved body trapped inside a glacier. But as science advanced and researchers began examining every inch of his remains, they realized they weren't simply studying an ancient corpse. They were opening a window into a forgotten world. Today, thanks to cutting-edge DNA technology and forensic science, Otzi is revealing secrets that are rewriting history books and forcing scientists to rethink everything they believed about Europe's earliest inhabitants. From his ancestry and appearance to his health, lifestyle, and even the final hours of his life, each new discovery paints a clearer picture of a man who lived over 5,000 years ago. But perhaps the greatest surprise is that the more scientists learn about Otzi, the more mysterious he becomes. The remarkable story began on a crisp September day in 1991 when two German hikers, Helmut and Erika Simon, were crossing the rugged Ötztal Alps along the border of Austria and Italy. High above sea level, nearly 3,120 meters up on the eastern ridge of Finnilspitze near Simelaun Mountain and the Tiesenjoch Pass, they noticed what appeared to be the body of a recently deceased mountaineer emerging from the melting glacier. At first, nothing about the discovery suggested they had stumbled upon one of archaeology's greatest treasures. Believing they had found the victim of a modern climbing accident, they alerted authorities. The following day, rescuers attempted to free the body from the thick ice using drills and ice axes, but severe weather repeatedly interrupted the recovery. As news spread across the Alpine region, experienced mountaineers, archaeologists, and scientists rushed to the remote site. Only after the frozen body and its scattered belongings were finally removed and transported to Innsbruck did experts begin to realize the astonishing truth. Archaeologist Konrad Spindler carefully examined the copper axe found beside the body and immediately suspected it belonged to a much older era. Scientific dating soon confirmed his suspicion. This was not a modern climber at all. The man had lived sometime between 3,359 and 3,501 BC, making him approximately 5,000 years old and one of the oldest naturally preserved human mummies ever discovered in Europe. From that moment forward, Otzi became the subject of one of the most comprehensive scientific investigations ever conducted on an ancient human being. Every available technology, from X-rays and CT scans to microscopic analysis and genetic sequencing, was used to unlock the story preserved inside his frozen body. Scientists determined that he stood about 1.60 meters tall, weighed roughly 50 kilograms during life, and was approximately 45 years old when he died, an impressive age for someone living during the Copper Age. Ironically, when his body was first recovered, it weighed only about 13.75 kilograms because the glacier had naturally freeze-dried him shortly after death, dramatically slowing decomposition. Initial reports even suggested parts of his body were missing, but later, examinations proved those early assumptions incorrect. Meanwhile, chemical studies of his tooth enamel, combined with pollen grains and isotopic evidence, revealed that Otzi spent his childhood near today's village of Feldthurns in South Tyrol, before later moving to valleys nearly 50 kilometers farther north. Piece by piece, researchers were reconstructing not just how he died, but where he had lived and traveled throughout his lifetime. One of the greatest breakthroughs came when scientists examined Otzi's stomach using advanced CT imaging. Surprisingly, they discovered that his stomach had shifted upward inside his body after thousands of years in the ice. Once they located it, they uncovered one of the best-preserved ancient meals ever found. DNA analysis identified partially digested ibex meat, proving he had eaten less than 2 hours before his death. Alongside the meat were grains of einkorn wheat, suggesting his final meal included dried, fatty wild goat meat and processed bread made from ancient wheat. His intestines revealed evidence of 2 additional meals consisting of chamois meat, red deer, herbs, roots, fruits, and more einkorn bread. Around his body, archaeologists found supplies including barley, flax, poppy seeds, berries, and sloes, providing an extraordinary snapshot of Copper Age nutrition. Hair analysis reached even farther back in time, preserving clues to what he had eaten months before his death. Fresh pollen trapped inside his digestive system indicated he had recently traveled through forests filled with tall trees before climbing into the high mountains during spring or early summer. Because some of the foods discovered normally ripened in autumn, researchers concluded they must have been carefully stored through the winter, revealing surprisingly advanced food preservation practices among early alpine communities. The deeper scientists looked into Ötzi's body, the more fascinating his life became. High levels of copper particles and arsenic were discovered in his hair, leading researchers to suspect he may have worked with copper ore or participated in copper smelting. His leg bones and pelvis showed signs of years spent walking across steep mountainous terrain, suggesting he may have worked as a shepherd moving livestock through high alpine pastures. Using sophisticated 3D scanning technology, experts at the South Tyrol Museum of Archaeology reconstructed his face with remarkable accuracy. The result surprised many people. Rather than appearing like a heroic warrior, Ötzi looked exhausted, weathered by a lifetime outdoors. His reconstructed face featured deep brown eyes, a full beard, wrinkled skin, and an expression marked by hardship. His health told an equally difficult story. Scientists discovered he suffered from whipworm parasites living inside his intestines, cracked ribs caused either by pressure from the glacier or his final moments, and repeated episodes of serious illness recorded as Bow's lines across one of his fingernails. His teeth were badly worn from a diet rich in coarse grains, while DNA analysis revealed he was lactose intolerant, showing that difficulty digesting milk already existed 5,000 years ago. His lungs were stained black with soot from years spent sitting beside smoky fires, painting an intimate picture of everyday life during the Copper Age. Yet, perhaps nothing about Ötzi fascinated researchers more than the mysterious markings covering his body. At first, many of them were nearly invisible against his darkened skin. Only after specialists photographed him using advanced imaging systems capable of detecting wavelengths beyond normal human vision did the complete pattern emerge. Ötzi carried an astonishing 61 tattoos arranged into 19 separate groups. They varied from incredibly thin lines to markings as wide as a grain of rice. Some stretched along his spine and legs, while others formed crosses behind his knees, around his ankles, and across his wrists. Most of them, however, were concentrated on his legs. Unlike decorative tattoos seen today, these markings appeared deliberate and functional. Scientists discovered they had been created by making tiny cuts in the skin before rubbing soot or fireplace ash into the wounds, producing permanent black lines. Many remained unusually dark, leading some experts to believe they had been refreshed several times during his life. As researchers compared the tattoos with the rest of Ötzi's body, an extraordinary pattern began to emerge. Areas containing tattoos almost perfectly matched places where his joints showed signs of arthritis and long-term wear. His lower back, knees, ankles, and other painful regions all carried tattoo markings. This observation led many scientists to propose that the tattoos were not decorative at all, but formed part of an ancient therapeutic treatment remarkably similar to acupuncture or acupressure. Even more astonishing, Otzi lived nearly 2,000 years before acupuncture is traditionally believed to have developed in China. 9 of his 19 tattoo groups lie almost exactly on acupuncture points still used by practitioners today, while many of the remaining tattoos align closely with important energy pathways recognized in traditional medicine. Some researchers even speculate that the markings on his abdomen may have been intended to relieve pain caused by the intestinal parasites discovered inside his body. Whether they represented medicine, ritual, or both, Otzi's tattoos transformed from simple body markings into one of archaeology's greatest medical mysteries. Hidden beneath the ice for over 5,000 years, they continue to challenge long-held assumptions about the knowledge and sophistication of Europe's earliest mountain communities, proving once again that the frozen man of the Alps still has many stories left to tell. But the tattoos were only the beginning. Hidden far deeper than the surface of Otzi's skin was an even greater archive, one written not in ink, but in DNA. Every cell preserved inside his frozen body carried a genetic record untouched for more than 5,000 years, waiting for technology advanced enough to read it. In 2012, scientists accomplished what had once seemed impossible by sequencing Otzi's entire genome, opening an unprecedented window into the life of a man from the Copper Age. Yet even that achievement proved to be only the first chapter. More than a decade later, in 2023, researchers returned to his remains with far more sophisticated sequencing techniques capable of separating Otzi's authentic DNA from tiny traces of modern contamination introduced during decades of handling and study. The result was the clearest genetic portrait of the Iceman ever produced, revealing details that earlier analyses had completely missed, and forcing scientists to reconsider long-held assumptions about his ancestry, appearance, and even the population history of ancient Europe. As researchers carefully pieced together his genetic code, they discovered that Otzi belonged to a remarkably rare paternal lineage known as G2-L91, a Y chromosome group now found most commonly in parts of southern Corsica. His maternal DNA told an equally intriguing story. It belonged to mitochondrial haplogroup K1, but there was an unexpected twist. Otzi's maternal lineage matched none of the previously identified branches within that family. Instead, his DNA represented an entirely new branch that had never been documented before. Scientists were so confident they had discovered something unique that they created a brand new subgroup specifically for him, naming it K1U in honor of the Iceman himself. It was an extraordinary reminder that even after thousands of years, ancient DNA can still reveal genetic lineages that have completely disappeared from the modern world. In many ways, it was like uncovering a forgotten branch of humanity's family tree that had remained hidden beneath the ice for 5 millennia. The surprises only grew from there. When researchers compared Otzi's genome with thousands of ancient and modern populations, they found that his closest genetic relatives were not the people living around the Alps today, but populations from southern Europe, particularly Corsica and Sardinia. His DNA pointed toward one of the greatest migrations in European prehistory, the spread of early farming communities from Anatolia in present-day Turkey into Europe thousands of years before his birth. For decades, archaeologists had reconstructed this migration using pottery, tools, and settlements. Now, Otzi's own DNA provided direct biological evidence that those farming populations had reached deep into the Alps. Even more remarkably, later genetic studies showed that his ancestry contained an unusually high proportion of these early Anatolian farmers, mixed with smaller contributions from Europe's indigenous hunter-gatherers. What researchers did not find was perhaps even more surprising. There was virtually no evidence of ancestry from the steppe pastoralists, whose migrations would later transform much of Europe's genetic landscape. In other words, Otzi represented a snapshot of Europe before one of its greatest population changes had even begun. His DNA also opened an unexpected window into his health. Scientists discovered that Otzi carried genetic variants associated with an increased risk of cardiovascular disease, suggesting that heart problems were not simply the result of modern lifestyles, but could also have deep hereditary roots stretching back thousands of years. Researchers also identified traces of the bacterium Borrelia burgdorferi, the organism responsible for Lyme disease. If the finding is correct, Otzi would represent the earliest known human ever identified with the infection, proving that tick-borne diseases plagued people long before recorded history. At the same time, his genes confirmed what scientists had already suspected from other evidence. He was lactose intolerant, unable to properly digest fresh milk despite living during the rise of farming communities. Together with the whipworm infection, worn teeth, arthritis, and evidence of repeated illnesses found elsewhere in his body, his genome painted the picture of a man whose daily life was far more physically demanding and medically challenging than anyone had imagined. Perhaps the most fascinating revelation, however, was not about where Otzi came from, but about what he actually looked like. Earlier facial reconstructions had portrayed him with relatively light skin, thick hair, and a rugged but familiar European appearance. The new DNA told a very different story. Researchers concluded that Otzi most likely had considerably darker skin than most Europeans today, although not quite as dark as some of Europe's earlier hunter-gatherer populations. His genes also indicated a strong tendency toward male pattern baldness, meaning he probably had much less hair than earlier reconstructions suggested. Combined with his naturally dark eyes and weathered features, the genetic evidence transformed our image of the famous Iceman almost overnight. After decades of believing they knew his face, scientists suddenly realized they had been looking at the wrong man all along. The frozen traveler emerging from the glacier looked very different from the image that had become famous around the world. The genetic investigation even reached into the present day. Scientists analyzed the DNA of more than 3,700 men living throughout the Tyrol region and made an astonishing discovery. 19 of them shared the same rare paternal lineage carried by Otzi. While separated by more than 5,000 years and countless generations, these men still carried echoes of the same ancient ancestry preserved inside the Iceman's genome. It was a remarkable reminder that although civilizations rise and disappear, fragments of ancient families can survive almost unnoticed, passed quietly from father to son across thousands of years. In a sense, Otzi's story never truly ended. Part of it is still walking through the Alps today. If his DNA revealed who he was, his clothing revealed how he survived. Every piece he wore had been carefully designed for life in one of Europe's harshest environments, demonstrating a level of craftsmanship that few people would expect from the Copper Age. Otzi wasn't dressed in simple animal skins thrown over his shoulders. Instead, he wore an expertly assembled outfit consisting of a woven grass cloak, a tailored leather coat, leggings, a loincloth, a sturdy belt, and a remarkable pair of shoes unlike anything previously discovered from that period. His warm cap, fashioned from bear skin and secured beneath the chin with a leather strap, protected him against freezing mountain winds. His footwear proved even more impressive. Constructed from bearskin soles, deer-hide uppers, and an intricate netting of tree bark, the shoes were filled with soft grasses that acted much like insulated socks, keeping his feet warm and dry while crossing snow-covered mountain passes. Modern researchers who recreated these shoes were astonished by their complexity, concluding that specialized shoemakers may already have existed more than 5,300 years ago. One reconstruction proved so successful that a Czech company even explored producing the design commercially. As scientists continued studying every stitch of Ötzi's clothing, they discovered that his outfit was far more sophisticated than anyone had imagined. Genetic analysis showed that his garments had been assembled from the hides of numerous different animals, each selected for a particular purpose. His loincloth and much of his coat came from domesticated sheep, while other sections had been stitched together using goat hide from multiple animals. His leggings were crafted entirely from domesticated goat leather, remarkably similar to another pair of 5,000-year-old leggings discovered at Switzerland's Schniederjoch Pass. Even the shoelaces revealed another surprise, having been made from European cattle leather, while his arrow quiver came from wild roe deer. Every material appeared to have been deliberately selected according to its strength, flexibility, or insulating qualities. Rather than representing primitive clothing, Ötzi's outfit reflected generations of accumulated knowledge about surviving in the extreme alpine environment. The equipment he carried was just as extraordinary. Alongside him lay an unfinished yew longbow measuring 1.82 meters in length, a carefully crafted flint knife with an ashwood handle, 2 birch bark containers, medicinal birch fungus, tinder mushrooms, berries, and an elaborate fire-making kit containing flint, pyrite, and plant fibers capable of producing sparks in almost any weather. His quiver held 14 arrows made from viburnum and dogwood. 2 were fully equipped with razor-sharp flint points and carefully attached fletching, while the remaining 12 were unfinished, suggesting he had intended to complete them later. Also tucked inside were an antler tool likely used for sharpening arrowheads, a bowstring, and several unidentified implements, painting the picture of a man constantly prepared for hunting, travel, or conflict. Yet among all of Ötzi's possessions, one object stood above the rest, the magnificent copper axe resting beside him in the ice. Its beautifully shaped yew handle measured around 60 centimeters and curved naturally into a right-angled grip that perfectly balanced the blade. The axe head itself was nearly pure copper, approximately 9.5 centimeters long, and secured firmly using birch tar reinforced with tightly wrapped leather bindings. Unlike many ancient metal tools, this blade had been cast rather than mechanically hardened, demonstrating advanced metallurgical knowledge for its time. Wear marks along the cutting edge showed it had been used repeatedly for chopping and woodworking rather than being carried solely as a ceremonial object. Then came another surprise. Chemical analysis published in 2017 revealed that the copper had originated not from nearby alpine mines, but from southern Tuscany, hundreds of kilometers away. That single discovery hinted at trade networks stretching across prehistoric Europe, connecting distant communities long before written history began. More than just a practical tool, Ötzi's axe represented wealth, influence, and status. In the Copper Age, few possessions could have carried greater value, making it one of the clearest signs that the mysterious man preserved in the glacier may have held an important place within his society. For years, the greatest mystery surrounding Ötzi wasn't who he was, but how he died. When his frozen body was first recovered from the glacier, many researchers assumed his story had ended, the way countless mountaineers' stories have ended throughout history, with a sudden winter storm. Alone, exhausted, and trapped by the brutal alpine weather, he was believed to have simply frozen to death. It was a logical explanation, especially given the hostile environment in which he was found. But as technology improved, and scientists looked deeper beneath his remarkably preserved skin, that peaceful image began to crumble. Others proposed a far more dramatic possibility, that Ötzi had been ritually sacrificed because he occupied an important position within his society, perhaps even serving as a tribal leader. Similar theories had been suggested for famous bog bodies like the Tolland Man and the Lindo Man, making the idea seem plausible. Yet neither explanation would survive the overwhelming forensic evidence hidden inside the Iceman himself. The breakthrough came when X-rays and high-resolution CT scans revealed something no one expected. An arrowhead was still embedded deep inside Ötzi's left shoulder. It had remained hidden for over 5,000 years beneath layers of frozen tissue. Even more telling was a small tear in his leather coat that perfectly matched the location of the wound. Suddenly, the entire investigation changed. This was no accidental death. Someone had fired an arrow into Ötzi from behind, and the projectile had penetrated his shoulder with devastating force. Modern medical experts concluded that the arrow almost certainly severed major blood vessels before lodging near his lung, causing catastrophic blood loss. Remarkably, the wooden shaft had been pulled out before he died, suggesting either Ötzi himself or someone else desperately tried to remove it. But by then, it was already too late. Even with today's emergency medicine, such an injury can be fatal within minutes. Thousands of years ago, it would almost certainly have been a death sentence. As investigators examined the rest of his body, the evidence became even more disturbing. Ötzi wasn't simply shot and left to die. His body carried bruises, cuts, and signs of severe physical trauma consistent with a violent confrontation. One wound in particular caught the attention of forensic specialists, a deep slash across the base of his thumb that extended all the way to the bone. The injury showed no signs of healing, meaning it had occurred only hours or days before his death. Many experts believe it was a defensive wound, the kind suffered when someone instinctively raises a hand to block a knife or axe during close combat. Combined with evidence of possible head trauma and the fatal arrow wound, the injuries suggest that Ötzi endured a desperate struggle shortly before climbing into the mountains. Rather than dying peacefully in isolation, he may have been fleeing attackers after surviving a brutal fight. Then came another astonishing discovery that made the mystery even more complex. DNA testing detected traces of blood belonging to at least 4 other individuals on Ötzi's equipment. Blood from one unknown person was found on his flint knife. 2 different people's blood appeared on a single arrowhead stored inside his quiver, while another individual's blood was discovered on his coat. These findings immediately raised dramatic questions. Had Ötzi defended himself against multiple attackers? Had he helped wounded companions? Or had he taken part in a larger conflict before making his final escape into the mountains? Scientists still cannot answer these questions with certainty, but the evidence strongly suggests that Ötzi's final journey unfolded against a backdrop of violence involving several different people. His possessions had become silent witnesses to a deadly